A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. If you head over to GitHub right now and type AI framework into the search bar, you get over 2,300 results. Switch that to AI toolkit, and you are looking at another 1,800. It is absolute bedlam out there. We are drowning in a sea of nomenclature that seems designed to confuse anyone trying to actually build something.
It really is a semantic soup, Corn. And honestly, it is more than just a naming problem. It is an architectural and ecosystem crisis. Engineers are spending dozens of hours every month just performing basic triage on these repositories to figure out if a framework is actually a framework or just a collection of 3 Python scripts someone wrote during a long weekend. By the way, quick heads up for everyone listening, the script for today's deep dive is actually being powered by Google Gemini 3 Flash.
Well, hopefully, Gemini can help us untangle this mess, because today's prompt from Daniel is about exactly that. He wants us to break down the confusing world of toolkits, frameworks, SDKs, libraries, packages, and modules. We're going to look at what these terms actually mean, technically and practically, and then we need to talk about the why. Why is there an endless parade of these things for every conceivable AI sub-problem, and who on earth is maintaining the long tail of these niche projects?
I love this topic because it hits at the intersection of technical architecture and human psychology. We like to think of software engineering as this purely logical pursuit, but the way we name things on GitHub is often driven by marketing, ego, and historical accidents.
Right, so let's start with the definitions, because I think a lot of people use these terms interchangeably when they really shouldn't. Let's start with the basics, the library versus the package versus the module. In the hierarchy of stuff you import, where do these sit?
Okay, let's go bottom up. A module is your atomic unit. In Python, for example, it is usually just a single file, a .py file. It is a namespace. You have some functions, some classes, and they live in that file. It's like a single chapter in a book. When you move up to a package, you are talking about a collection of modules bundled together with some metadata. Think of a pyproject.toml or a package.json. It is a distributable unit. You install a package using a manager like pip or npm.
So if the module is the chapter, the package is the physical book you buy at the store.
That's a great way to put it. The package is what has the barcode and the shipping label. And then a library is the conceptual collection of those things. It's the library building itself, or a specific wing of it.
And the defining characteristic of a library is the relationship between the code and the developer, right?
A library is a collection of reusable, non-volatile routines. The defining characteristic of a library is that you call it. You are in control of the program flow. You say, hey NumPy, calculate the dot product of these two arrays. NumPy does the math and gives control back to you. It is a tool in your belt. You decide when to take the hammer out, how hard to swing it, and when to put it back.
Okay, so that is the library pattern. I am the boss. The library is the specialized contractor I hire for a specific task. But then we hit the big one, the framework. This is where I feel like the marketing departments have really poisoned the well. Everything wants to be a framework now because it sounds more substantial, doesn't it?
It sounds much more prestigious. But technically, a framework is defined by inversion of control. In a framework, the framework calls you. Think of something like Django or TensorFlow. You don't just call a make website function in Django. Instead, you write your code within the structure Django provides, and then you tell Django to run. It handles the request-response cycle, the routing, the database connections, and it calls your specific view function when the time is right.
It is the don't call us, we'll call you principle of software.
Precisely. If you are building inside a framework, you are essentially filling in the blanks of a predefined architecture. Libraries are bricks, frameworks are the blueprint and the foundation. And this distinction is vital because the switching cost for a framework is massive compared to a library. If you want to swap NumPy for a different math library, it might take an afternoon of refactoring. If you want to swap TensorFlow for PyTorch, you are basically rewriting your entire application logic.
But how does that work in practice when people use hybrid tools? I mean, look at PyTorch. People call it a library, but it feels like a framework when you're defining a model class.
That's where the lines get blurry. PyTorch started very much as a library. It was imperative, meaning you execute line by line. But as the ecosystem grew with things like PyTorch Lightning, it shifted toward a framework model. Lightning literally takes over the training loop for you. You just provide the data and the model architecture, and Lightning decides when the epoch starts and ends. That is pure inversion of control.
Which brings us to SDKs, software development kits. These feel like a different beast entirely because they usually come from a specific vendor. If I'm using the OpenAI SDK or the AWS SDK, I'm not just getting code, I'm getting a whole starter pack, right?
Right. An SDK is a bundle. It usually includes libraries, but also documentation, code samples, maybe some specialized compilers or debuggers, and often an API wrapper. The goal of an SDK is to make it as easy as possible to integrate with a specific platform. So while a library is general purpose, an SDK is platform specific. It is the onboarding ramp for a commercial service.
Think of it like a build-your-own-furniture kit from IKEA. The SDK is the box that has the wood, the screws, the hex key, and the wordless instructions. You aren't just getting the materials, you're getting the specific tools needed to assemble those specific materials.
That's a perfect analogy. You can't use the IKEA hex key to fix your car engine. Well, you shouldn't. Just like you wouldn't use the OpenAI SDK to manage your Azure Blob storage. It's a closed-loop ecosystem.
So if I'm a developer, I'm looking at an SDK as a way to talk to a specific company's product. But then we have toolkits. This is the term that drives me the most crazy on GitHub. Hugging Face calls their Transformers repo, a library in some places, and a toolkit in others. What is the technical definition of a toolkit?
That is the trick. There isn't a strict one. In practice, toolkit is usually used for a domain-specific collection of tools that might include both libraries and scripts. It is often broader than a library but less restrictive than a framework. If a library is a hammer and a framework is a workshop where you have to follow the house rules, a toolkit is a specialized toolbox for, say, plumbing. It has a bunch of different tools that are designed to work well together for a specific set of problems, but it doesn't necessarily dictate your entire program's architecture.
It feels like toolkit is the word you use when you have a bunch of useful stuff, but you haven't quite figured out how to turn it into a cohesive framework yet, or you want to sound approachable. Framework sounds like a commitment. Toolkit sounds like a helping hand.
There is definitely a psychological element there. And you mentioned the marketing aspect. This is where the chaos starts. On GitHub, framework is a high-value keyword. If you want stars, if you want visibility, calling your project the next-gen AI agent framework is going to get more clicks than a collection of utility functions for LLM prompting.
Even if it is just a collection of utility functions.
Especially then, we see this semantic inflation all the time. Projects claim to be frameworks to signal maturity and importance, even if they don't actually provide an inversion of control. And that leads to Daniel's bigger question. Why are there so many of them? Why do we have 4,000 different AI frameworks and toolkits floating around as of early 26?
I think part of it is that the barrier to entry for being a framework author has never been lower. In the old days, if you wanted to release a framework, you needed a massive manual, a distribution stable, and a community. No, you just need a GitHub repo, a halfway decent README, and a pip install command. You can become a framework author in an afternoon.
And the incentives are completely skewed. If you are a PhD student or a researcher, and you develop a slightly more efficient way to handle attention mechanisms or memory retrieval in RAG, Retrieval Augmented Generation, you don't just write a paper. You release a framework. Because a paper gets cited, but a GitHub repo with 5,000 stars gets you a job at OpenAI or a $10 million seed round.
It is the GitHub resume effect. But it creates this massive long tail of niche projects. We're not just talking about the big players like LangChain or Llama Index. We are talking about projects like AutoGPT TurboKit or niche medical LLM framework. Who is actually maintaining these things?
That is the scary part. A GitHub study from 25 looked at these niche AI repositories and found that a staggering percentage of them, I believe it was over 60%, are effectively abandoned within 18 months of their initial release. They are flash-in-the-pan projects. Someone has a great idea, they get their initial burst of stars, maybe they get the job or the funding they wanted, and then the maintenance stops, but the code is still there. It is still appearing in search results. People are still building production systems on top of it.
It's like a digital ghost town. You walk in, the lights are on, there are signs pointing everywhere, but there hasn't been a soul in the mayor's office for a year. And in the AI world, a year is an eternity. If your framework hasn't been updated since mid-25, it is basically a historical artifact. It probably doesn't support the latest model architectures, the latest quantization methods, or the latest security patches.
It's actually worse than that. Think about the dependency hell this creates. If Framework A depends on Library B version 1.2, but Library B has moved on to version 3.0 with breaking changes, Framework A just stops working for anyone trying to do a fresh install. We see this all the time with niche AI projects that were built for a specific version of CUDA or a specific release of the OpenAI API that has since been deprecated.
And yet, these niche toolkits are often solving very real, very specific problems that the big vendor SDKs haven't touched yet. If you are doing something highly specialized, say edge deployment of vision models on specific low-power hardware, the official AWS or Google SDK might be too bloated or just plain missing the features you need. So you turn to a niche toolkit.
Right. There was a case last year where a small research group released a toolkit specifically for optimizing LLMs to run on old gaming consoles. It was a total hack, but it was the only way to do it. If you were a developer trying to build a retro AI game, that abandoned repo was your only hope. You end up having to fork the graveyard.
But then you're taking on maintenance debt by proxy. If the original author vanishes, you are now the de facto maintainer of that toolkit for your own project. I think we need to talk about whether this proliferation is actually healthy innovation, or just chaotic noise. Because on one hand, I love that anyone can contribute a piece of the puzzle. On the other hand, it makes the discovery phase of any project a nightmare.
I think it is a bit of both, but we are definitely leaning into the noise territory right now. The problem is that we lack a standard library for AI. In the web world, we eventually coalesced around a few major patterns. In AI, the underlying technology is moving so fast that the patterns haven't stabilized. What we call a best practice on Monday is obsolete by Friday. This speed prevents consolidation.
It also creates what I call the shiny new thing trap. Developers, and I am guilty of this too, love the idea of using the most cutting-edge tool. We see a new repo on trending. It has a cool logo. It promises to solve the problem with 3 lines of code, and we jump on it. We don't stop to ask, will this person still be answering issues in 6 months?
And that is why the distinction between a library and a framework is so important here. If you use a niche library for a specific task and it goes stale, you can replace that library. If you build your entire application logic inside a niche AI agent framework that gets abandoned, you are in deep trouble. You are basically married to a ghost.
So how do we vet these things? If I'm an engineer looking at one of these 1800 AI toolkits, what is my checklist? Because we can't just ignore them all. Some of them are genuinely brilliant.
You need a rigorous vetting process. I call it the 4 pillars of sustainability. First, look at the last commit date. If it hasn't been touched in 3 months in this ecosystem, it is a red flag. Second, look at the contributor count. Is this a hero project with one person doing 90% of the work, or is there a genuine community? If that one person gets a new job or loses interest, the project dies.
That bus factor is huge. If the maintainer gets hit by a bus, or more likely, gets hired by a big lab, what happens to the code? We saw this with a few popular prompt engineering frameworks in 24. The lead devs got swallowed up by Anthropic and OpenAI, and the repos just froze.
It's a victim of its own success. Third, look at the issue resolution time. Don't just look at the number of open issues. Look at how quickly the maintainers are responding to them. Are they engaging with the community? If there are 300 open issues and the last comment from a maintainer was in 2024, run away.
I'd add a fifth pillar, integration density. How many other projects are using this? If a toolkit is being used as a dependency by 500 other repos, it has a much higher chance of being community rescued if the original maintainer leaves. There is a collective incentive to keep it alive.
That is a great point. It is why something like NumPy will never truly die, even if the core team changed tomorrow. It is too foundational. But these niche AI frameworks often have an integration density of near zero. They are leaf nodes in the ecosystem.
Let's talk about the long-tail maintainers for a second. These aren't the guys getting the multi-million-dollar checks. These are often just engineers who had a problem, solved it, and were kind enough to share the solution. I feel for them, because maintaining a popular repo is a thankless, unpaid second job. They get flooded with, "This doesn't work on my specific Windows setup issues," and "Why haven't you added this feature yet?" demands.
It is the open source burnout cycle. You release something cool, it gets popular, you get overwhelmed by the demands of strangers, you realize you aren't getting paid for this, and you eventually just stop checking the notifications. It is a completely rational response to a broken incentive structure.
Do you think we're going to see a consolidation event soon? Like, will the great AI framework war end with one or two winners, or are we stuck in this fragmented state forever?
I think we'll see consolidation at the orchestration level. We're already seeing LangChain and Lalem Index try to become the Linux of AI. But at the toolkit level, the specialized tools for fine-tuning or data synthetic generation or specific model evaluations, I think fragmentation is here to stay. The field is just too broad for one company or one community to own it all.
So, is the answer more vendor SDKs? Should we just wait for the big three, Google, OpenAI, Anthropic, to release official tools for everything? Because that feels like it would kill innovation.
It would definitely slow things down. The vendor SDK approach is stable, but it is also a moat. They are only going to build tools that make it easier to use their services. They aren't going to build a cross-model fine-tuning toolkit that makes it easy for you to leave them. We need the community-driven toolkits to keep the vendors honest and to push the boundaries of what is possible.
It's the classic tension. The vendors give us the Home Depot experience. Everything is standardized. It works, but you're limited to what's on the shelf. The open source long tail is like a maker faire. It is messy. Things explode, there are no instructions. But that is where the truly weird and wonderful stuff happens.
And I think we are seeing a new category emerge, the corporate-backed open source project, things like Meta's Llama ecosystem or Mistral's tools. They aren't quite vendor SDKs in the traditional sense, but they have the resources of a major company behind them. That might be the middle ground we're looking for.
But even then, Meta isn't going to maintain the niche medical LLM framework. They're going to maintain the foundation. We are always going to have this fragmentation at the edges. I guess the real question is this fragmentation a bug or a feature?
In the short term, it feels like a bug because it is confusing. In the long term, it is a feature. It is a massive, decentralized Darwinian experiment. We are throwing 4,000 different framework ideas at the wall, and 95% of them are going to fall off and be forgotten. But the 5% that stick, the ideas that actually work, will become the foundations of the next decade of computing.
So the noise is actually just the sound of the evolutionary process.
You can't have the breakthroughs without the thousands of failed experiments. The trick for us, as developers and users, is to not confuse an experiment with a production-ready foundation.
That is the takeaway, isn't it? Use the niche toolkits for your experiments. Use them to learn. Use them to see what is possible. But when you are building the mission-critical stuff, you need to be very, very careful about who you are inviting into your code base.
And be honest about the nomenclature. If you're building something and putting it on GitHub, ask yourself, is this really a framework, or am I just trying to sound cool? If it is a library, call it a library. If it is a collection of scripts, call it a toolkit. Precision in naming helps everyone.
Good luck with that. We are talking about an industry that named a programming language, Java, and a cloud service, Azure. We are not exactly known for our linguistic precision.
Fair point. but we can dream.
Let's do a quick fun fact before we wrap, because I was looking into the origins of the word framework in software. Did you know it didn't really take off until the late 80s with Smalltalk?
I didn't. Smalltalk was ahead of its time in so many ways.
Yeah, specifically the model view controller pattern. Before that, everything was just libraries. But Smalltalk introduced this idea that the system should provide a living environment that your code lives inside of. It was the birth of inversion of control as a mainstream concept. It took us 30 years to turn that useful architectural concept into a GitHub marketing buzzword.
That sounds about right for our industry. 30 years to perfect the art of confusing each other.
So, to summarize the semantic soup for Daniel, a module is a file, a package is a bundle, a library is a tool you call, a framework is a structure that calls you, an SDK is a vendor's everything-included starter kit, and a toolkit is a specialized toolbox for a specific job.
And the reason there are thousands of them is because everyone is trying to build the one tool to rule them all, and in the process they are just adding more noise to the signal. But within that noise, the future is being built.
It's like that old XKCD comic about standards. There are 14 competing standards. This is ridiculous. We need to develop one universal standard that covers everyone's use cases. Situation, there are 15 competing standards.
That is the AI ecosystem in a nutshell. We see a new unified agentic framework every Tuesday.
And by Wednesday, there's a toolkit to help you migrate from Tuesday's framework to the one coming out on Thursday.
It's job security for someone, I suppose.
Well, hopefully that clears things up a bit. We've gone deep into the what and the why, and I think the practical takeaway for anyone listening is check the commit history before you npm install your future.
And if you are a maintainer of one of those niche toolkits, thank you for your service. We know it's a grind.
Truly. The unsung heroes of the long tail. We should probably wrap it there before we start diving into the history of C++ headers or something.
That is a rabbit hole I'm not ready for today. I've had enough semantic soup for one afternoon.
Wise choice. Huge thanks to our producer Hilbert Flumingtop for keeping the gears turning and ensuring our own podcast framework doesn't collapse under the weight of its own nomenclature.
And a big thank you to Modal for providing the GPU credits that power our generation pipeline. They make it possible for us to do these deep dives every week without our hardware catching fire.
This has been My Weird Prompts. If you found this breakdown useful, or if you're currently rebuilding a project because your favorite framework went ghost, let us know. You can find us at myweirdprompts.com for the RSS feed and all the ways to subscribe.
See you in the next one.
Later. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our